You go to your supermarket, perhaps it's a Whole Foods, you see a piece of fish you like. It's neatly packaged in fillet form. It looks like a salmon fillet. You're happy with it, you take it home, and that's the theory. The photo above represents two different types of fish, side by side in fillet form. Even highly trained seafood chefs have difficulty telling them apart. The fish you just bought, the salmon, 30% chance it's not salmon at all. Could be trout, could be something else. Since most fish ends up in fillet form sooner or later, it's a bit of a coin toss. No wonder the word fishy has such negative connotations. So what's our technological solution? Infrared spectroscopy and machine learning. When you emit infrared light on a substance, there's light that comes back that will indicate what that substance is, even if that substance has no clearly identifiable physical characteristics in human visible light. So it's not a new technology. It's been around for decades. And it's most commonly used in the pharmaceutical industry. Naturally, you want to be sure that whatever you're distributing is exactly what the doctor prescribed. But the problem with this is that it's quite expensive. And the margins in the fish industry aren't what they are in the pharmaceutical industry. So it's less justifiable as a cost for the marine industry. It's also big and bulky. And when you have a tightly controlled supply chain, that works. The medication leaves the manufacturer, goes directly to the pharmacy in a highly secure area. A single pharmacist has to sign off each and every time a medication is dispensed. In that context, a single IR spectroscopy machine at the manufacturer site works. But in the fish world, it's anything but a tightly controlled supply chain. Fish is the most internationally traded food commodity in the world. The fish fillet you picked up, odds are it's from abroad. As Jake mentioned, 90% of seafood in the US is imported. And not only does it cross several countries, several borders, but it exchanges hands amongst a whole slew of intermediaries. And it is this very permeability of the supply chain and near absolute visual similarity of fish in the fillet form that proves to be fertile ground for fraudsters to substitute fish. So, what have we decided to focus on? We can't have a single machine anywhere, and it has to be cheap, and it has to be portable. So what we've done is we've used machine learning to reduce the, we've finalized a set of components to try to decrease the size, but inevitably the precision is not as good as the lab equipment. But in order to compensate for that, we've used machine learning. And a good analogy here is Shazam, the music recognition service. You don't need the latest iPhone in order for it to work properly. You can even use a cheap phone with a rudimentary microphone, and it will do. It will generate sound waves, match those waves to the database. The machine learning will try to discern a pattern and separate the signal from the noise, if you will, and give you an educated guess about what the ID of the song is. And we pretty much do the same thing. And with this approach, we've been able to narrow down the cost to $500 per unit. We're currently manufacturing these units right now, and they will be distributed to our partner Seafood Watch by the end of the year. Our vision is to have these units spread far and wide throughout the fish supply chain to make fish fraud a thing of the past. But we need your help. In particular, if you know of any fish buyers for supermarket chains that value the integrity of their fish and we'd love to hear from you. Also, if you have any other ideas about how to push the project forward, let's have a chat. Fishazam. Together, let's make the fish business less fishy. Thank you.